Hello everyone, welcome to QSI seminar. Today we have our plenary on Elija Perrier, who will tell us about the ethics in quantum computing. Thanks, Elija. Take it from here.
Thanks for that introduction. Hi everyone. So if you don't know me, I'm a PhD student with Chris Ferries and Jiacheng Tao's. I do QML mainly with a focus on geometric QML, but I also have a side hustle. I'm a research affiliate at the ANU, where I combine some of my background in quantum with economics and the law. And as part of that work, I've sort of, over the last year or so, I've been combining it to look into this emergent hype-filled field of quantum ethics. So this is the sort of general interest in how quantum technologies and the implementation of things like quantum algorithms may be subject to a set of constraints to meet ethical guidelines. So what I'll do today, I'll present very briefly a sort of high-level overview, and apologies, I haven't actually updated these slides for a while, and we'll just sort of set out some of the concepts, maybe for this audience, maybe for people that don't have a background in ethics. And then I'll talk briefly about some of my sort of work I've been doing with a few groups, including at the World Economic Forum and on the policy front. So to kick off, ethical quantum computing roadmap. So I'll be talking about what people mean by this sort of concept of ethics in quantum computation. People in the sciences, and particularly in, dare I say, quantum world, have a rightly very highly tuned antenna for hype and for being very aware of some of the differences between how quantum technologies and quantum computing is portrayed in the press and the challenges and actual state of the art if you have a technical background like people like we do in our group. So the first part of the talk is going to be trying to sort of set the scene, as it were, for why anyone should care about quote unquote quantum ethics. So why are there ethical questions, if there are ethical questions, around the use and implementation of quantum technologies? And then I'm going to skip over the basic characteristics of quantum. I often give this talk to people that don't have any scientific background whatsoever, and for whom quantum means sort of whole host of things which it doesn't mean to people who are actually practicing quantum. So I'm going to skip over that background. I'm then going to sort of talk briefly about how you combine the concept of like doing ethics with concepts from computer science. And the kind of focus of that is going to be, there's a whole subfield of computer science, which I'll briefly talk about, which is called fair machine learning. So that's the idea that when you are building an algorithm or a computational platform, you need to make sure that it complies with certain ethical constraints. For example, you've got to make sure that your home loan algorithm is not racist, for example. You may need to make sure that your algorithm that you're using to do A, B, C doesn't adversely impact in a way that's illegal or unethical on some group. This is a big deal. You can have a whole career in this subfield, and you can get jobs at investment banks, Google, Facebook, so on and so forth. So you've probably seen this sort of field of, hey, there are jobs and research positions coming out in classical ML around, hey, how do we make sure that the algorithms that we are using don't kill us all or don't exacerbate existing inequalities? And so part of the work I've been doing is trying to look at, well, does anything change if the algorithms run on a quantum computer? So do the ways that we intervene, do the ways that we frame what it means to control the system or order the system change? And I wrote a paper about this year. I'll be talking about some of the ethical kind of concepts around the impacts on privacy and cryptography. And I should just say these slides are very so these slides are very high in these slides, I've often just glossed over technical points for an audience because oftentimes I don't want to get bogged down in, you know, BPP equals BPP, that kind of thing. I'll be taking a quick skip through some different fields of ethics. So if you study ethics, there's a whole different sort of, as we have in our subfield, there's a whole sort of subfields of ethics. And talking about the conclusion, what I've been up to, what I've come from. So as I said, this is a talk about the ethical consequences of quantum technology, which includes quantum algorithm design and more broadly, sort of tech which is uniquely only possible due to some aspect of controllable quantum systems. I'll be talking, as I said, about what issues arise as a result. So why quantum ethics? Is there anything unique about quantum ethics? There's a whole, if you are interested, there's a whole, you could spend your life reading ethics principles on technology. There are ethics principles for biotech, AI, chemical weapons, so on and so forth. There are treaties around some of these issues. There are whole sort of laws around this. So the first question is, why would we need to do anything different when it comes to quantum? Is this concept of quantum ethics as a distinct subdiscipline well motivated? And I answer yes. And why do I answer yes? Well, my claim is that there are some unique aspects of quantum computing which affect the ways in which one may seek to control quantum systems, or seek to ensure that certain ethical constraints on the functioning of algorithms are undertaken. Now, again, these slides are for an audience that doesn't have a background in quantum, but there are certain unique features of quantum which are distinct, not somewhat distinct from classical computing. And, you know, I should say it's not exactly known, and in what ways exactly, for example, trying to implement ethical constraints on a quantum algorithm may differ from a classical algorithm, because oftentimes classical algorithms, we don't truly understand how it's functioning if you build a sort of deep ML stack. But key features, again, this is for a lay audience. There are features which are distinct about the nature of quantum computation. Now, I'm not going to get into debate about the complexity classes, but generally speaking, if, you know, I should update these slides. If it's possible to solve certain classically intractable problems, it may mean that, for example, if the reason that solving a problem is not ethically problematic because we can't solve it, and then suddenly we now have a way of solving a problem, or the frontiers of computation expand, so that a certain set of problems which weren't able to be solved, or which couldn't be solved given our computational resources, if they can now be solved, then in theory, if those problems then give rise to ethical issues, then that is a consequence. For example, that may be a consequence. And again, I sort of always talking in the sort of potential sense. That may mean that as a result, we need to consider the nature of that, how one would govern the use of those technologies which expand the frontiers of computation. The classic example is the potential to decrypt certain encrypted information in a way that may not be possible classically. I'm going to skip over the technical characteristics of quantum. This is essentially blah, blah, blah. So apologies just for skipping through this. So, so let's go to ethics and ethical algorithms. So this is one way it may help people who maybe don't have a background to think about the role of ethics and computation. I'm going to focus on computation here. So one way to think about how you combine ethics and computer science, or quantum information processing, is to consider sort of what it means to classify either computation or the results of computation as ethical. So one way, so what is ethics? So generally speaking, and again, I'm not going to go do a deep dive into the nature of ethics. We'll be here till the heat death of the galaxy, is that we are concerned by what's called normative ethics. So these are rules or norms about what ought to be done. You're like, yep, that's obvious. So what is computation? Well, it's useful, again, we're not sort of going into our sort of church Turing thesis land here. We're just sort of trying to frame how we can combine concepts from ethics with concepts from computation and then expand that to quantum computation. So it's often useful to use the typical ends means distinction. So we may distinguish between dynamic processes and static states of computation. So again, think of the process of computation versus the outcome of the computation. And it's useful to again, just use that really basic framing again. There are whole subfields that go into how one properly characterizes computation in a way which connects with ethics. Again, you can sort of jump into the fair computation literature if you're interested. But this concept of there's a computational process or a computational outcome is useful when we want to apply an ethical taxonomy. So what's an ethical taxonomy? It's a way of classifying either the processes, as in the way that algorithmic computation is undertaken, or the outcomes according to ethical criteria. So, and this is drawn from general work on classical computation, but you may consider, so we have two concepts. There is an ethical procedure. So this is sometimes called algorithmic deontology. So deontology is a term from ethics. It really covers the concept of the rules and obligations and duties that people have. But fundamentally, one useful way that I find characterizing deontology, because it can be a vague concept, is with this idea that, well, a rule sets out a type of procedure often. So I must, if I have, I must not run through a red light. That is a deontological statement. And so you can then sort of take this concept of deontology and say, well, okay, so in a computational sense, deontology covers rules about the way that a computational procedure unfolds. CSIRO used to have a deontological logic division, for example. And so that was a division which tries to look at how can we frame and construct code to read laws and then to, if you like, go through and reason using those laws. So that was, I don't know if that division is still at CSIRO, and got rolled into something else at Data 61. But that's a useful idea. So then when we come to quantum, one useful way is, for example, is to understand okay, so we're talking about quantum systems and we want to think about the process of quantum computation. So we're thinking about what the nature of how the system evolves, and that's characterized obviously by the Hamiltonian. And so again, in a really basic sense, if there are ways that a computation should or should not unfold. So if I'm doing a computation, so if I'm using a quantum computer to work out who gets a home loan, because I think for some reason that's more effective use of resources, and the law says when I do a computation to who gets a home loan, I can't consider someone's gender or race, for example. Then to meet that algorithmic deontological requirement of the law, then one may need to then start thinking, well, what does the form of my Hamiltonian look like? So in classical computation, so if you work for an insurance company or maybe a bank and you're considering giving out home loans, you will need to dig into the code and check that, for example, you aren't using what are called protected attributes. So you aren't building an algorithm which only gives men home loans, for example. And in order to do that, you need to understand how the computation unfolds. So in an ethical So in a quantum sense, what this means is you would need to consider how these exogenous constraints impact the form of the Hamiltonian, which characterizes the quantum algorithm of interest. And then a second way, again, is to think about how to combine ethics and computation. And ethics and quantum computation is through the concept of ethical outcomes. So if you study ethics, or if you're interested in it, there's a whole subfield of ethics called consequentialism. And that's the idea that whether what you ought to do, for example, should be based on doing the greatest good. So utilitarianism, you know, is a classic example, as in what ought to be done is a function of the consequences. Now, sometimes there's a hazy blurring of deontology and consequentialism, because the reason we have rules like don't drive through a red light is because of the consequences. And there's some interesting work on combining these two in a computational sense. But when it comes to quantum computing, so one may think about, well, I have run a computation and I sort of don't entirely know how it's been run, but in the end, all the information which I want, as in who to give a home loan to, is encoded in the measurement statistic of the final quantum state of interest. And so one may say that instead of imposing ethical constraints on the way the computation is unfolding, I just say that there's a set of prescribed states. So the system must not evolve into a subspace of the Hilbert space where, for example, where there's an unacceptable correlation between getting a home loan and being mad, for example. So that's a way to sort of think about, okay, so rather than try to sort of open up the black box and because as we know, we cannot be certain exactly how quantum computation may unfold, we may say, well, in that case, we just care about outcomes. And so in a classical sense, this is often the case. I may be at Google and I may be concerned. So Google, for example, I remember being at a conference and they were like, okay, so we filter out algorithms so they don't, for example, classify by gender. But then we noticed that our deep neural network reconstructed a feature of gender, even though we took out gender. And so then for this particular use case that Google had, they said, well, in that case, we can't control what the abstract features are that the neural network is constructing. Therefore, we're going to say, rather than focus on making sure that the concept of gender is not a feature in the algorithm, we just make sure that the outcome, that the states meet certain criteria. So I'll spend a bit of time on that because it's kind of helpful to just sort of frame in your mind, okay, I've got this concept of computation, process and outcomes, these two concepts from ethics, deontology and consequentialism. This is I found this a somewhat useful way to combine those in order to then start thinking about what ethics looks like in a quantum context.
Can I have a question? Nishi?
Yeah. Yes, sorry. Please do.
My question is like, if we are considering, like, let's give the example of gender and race while considering a home loan or a perform, like something like that. Yes. Why can't we just turn the features off from the source data?
That's a very good point. Okay, so there are two answers to that. The first answer, for example, is that sometimes the algorithm can reconstruct a feature that looks like gender. So this is what Google faced. Google gave a presentation at AAAI a couple of years ago, and again, it's not only Google that's faced this. This is a well-known problem about the fact that you may take out gender in your training data. But you may then have a whole other set of features which are highly correlated with gender or some other protected class. And so what Google found and other teams have found is that is that the algorithms can reconstruct features that were taken out. Okay, so a classic example is, let's take out race. So off the top of my head, I don't have the site for the paper, but effectively, one other famous example is people tried to take race out of an algorithm, but then they found that the algorithm was not giving home loans, I think it was, to people that lived within a certain distance away from the CBD. And it just so happened that that distance from the CBD was where a lot of African American people live, because the algorithm had effectively internally reconstructed the concept of race. So that's the first answer. And then quickly, the second answer is actually sometimes you actually, whether you should take out a feature is all dependent on your concept of what's fair, and there's no set agreement on what is fair. That's why we have politics, right? And so sometimes if you take out too many features, you can mask the fact sometimes that certain classes are not being treated equally. So sometimes if you take out a feature and you say, well, okay, so we don't put race and gender in the algorithm, but that might not then allow you to work out that people of a certain race or gender are still being disadvantaged by the algorithm because you haven't kept the feature in. So there's a whole, again, it's very interesting, and there's a whole serious debate, and not just in research groups, but in the Googles and the Facebooks of the world as to how to deal with this problem. Yeah. And yeah, that's a long answer to your question. I hope that helped.
Sure.
I'm going to skip through it. Sorry, yeah.
Yeah, that's what I was thinking, like two things. First of all, you take out the things that is, you say, inherently biased. And second is like, even if you consider, and that is very low in terms of feature importances of the algorithm, then also it proves, immaterial, whether the gender is considered or not. So in those two cases, like I was like, you are right, like it can construct a feature like that. That will only happen in terms of neural networks or something. But I'm not having, we could consider that one. But how do you classify it? That even if it creates a feature like that, you cannot identify that feature, isn't it? If you take out something.
Well, yeah, but it sort of depends, because you may find, for example, you may then take a list of where everyone lives who has not been given a home loan, and you just essentially how it's often done is then you run a correlation analysis, and you find that correlates extremely highly with being of a certain race, and so that often, again, that is often what people use to give an indication that the algorithm has reconstructed a particular feature. Now, also there's a whole subfield as to how you computationally encode concepts of fairness. So I don't know if you're familiar with differential privacy, for example, but Cynthia Dwork, who's she basically came up with a lot of the algorithmic protocols for differential privacy. She's also known for coming up with a lot of the protocols of fairness in algorithm design. So she's got a lot of very interesting work, and I actually took some of her work and turned did the quantum version of it in another paper I did.
Yeah, definitely. I'll have a look into it. Definitely. Thank you.
Yeah. I might skip. I probably won't get through everything, but if anyone's got any questions or you're like, that doesn't make sense, jump out. So, let's say you design an algorithm, and again, the kind of big question everyone might have will be, well, hang on, but what would the algorithm look like on a quantum computer for giving out home loans, and how would that differ from classical? And the answer is, I don't know. This is very new research. And I should say, it's not, if you're interested in this subfield, do let me know, because there are no, not to float my boat on it, but there are 2 papers on it, and they're both by me. So I would love to chat with anyone who's interested in this. So you may want to audit you may say to someone, my quantum algorithm, when I run it to give out home loans, it meets these ethical criteria. And then someone says, I don't believe you. So then there's this question of proving, or essentially how do you audit a So how do you audit your computation? So there's a whole subfield around how you audit computations classically. Then there's a whole subfield of auditing to meet fairness criteria. And if you're interested in some papers, Kearns has got some, so people who do complexity will know Kearns. And as you would be unsurprised to hear, there's no, if you like, global national equilibria for fairness constraints because they often are not well founded. So there is no optimal way of constructing an algorithm that meets all fairness constraints. This should be, again, it's so obvious, it doesn't need to be stated, but sometimes it does need to be stated in other subfields, which is the fact that you always have trade-offs. So sometimes your concept of fairness might be two people who look the same should have the same outcome, but that's often inconsistent. In fact, you can actually show that that can be inconsistent with a second concept of fairness, which is called group fairness, or what's called statistical parity, which is that people in different groups should have the same type of outcome. So that's an issue that you often don't have a proper definition of fairness. There is no single definition of fairness. But then there's this question of how you audit. So sometimes it's challenging to audit to see, hey, has my home loan complied? And then I guess part of the case I make in one of my papers, which I've got the peer review back, I've got to do some changes on, is that the ways that we intervene are different. And again, so I'm not claiming that I have all the answers, but that how you audit and how you control quantum systems is different from classical systems. We know this. I'm sure most people here have done some quantum control. And again, I sort of got some points here about kind of, how and why quantum computation is different from classical computation, but it means the distinct differences in the nature of computation certainly give rise to the potential that the way that you audit and control the system is different from a classical computational system. And so then there's this question of, well, okay, so now for certain classical computations, you cannot fully audit them. In fact, for most of them. So you may just have to take a sample of the output, or you sort of check one of the computational runs if it's this stochastic algorithm. So laws, for example, are often drafted in a very deterministic way that imply you have access to full information about how a process works. And that is not going to be the case with a quantum computation. So laws may need to be redrafted when we're talking about quantum algorithm and the application of ethics to quantum algorithms. In fact, they should probably be redrafted just simply in terms of how those laws apply to classical algorithms. And this is a point I've been having a chat with a few professors at law school at Sydney Uni about, and I'm writing a paper on this concept as well. So the idea is that oftentimes the ethics doesn't, so what I say to my colleagues at the ANU and elsewhere when it comes to ethics is you may have this concept of ethics, but you need, at least if you're concerned about making sure that your quantum algorithm ticks certain boxes, you need to factor in the constraints as to how quantum computation works, how you can how you can control, and how you can audit it, because that will affect what is possible. So don't go thinking you have some sort of oracular access to information and that therefore that allows you to control or audit a quantum system in this particular way. It sounds really obvious to people in this group, but I tell you, it is not obvious to most people who hear quantum and think you can just control quantum in the same way.
Yeah, can I just ask a couple of questions about that? Because
yeah, please do.
Yeah. So it seems to me that there's this notion of auditing that you're trying to use, but to me, an audit, like being auditable, requires that there is an auditor. So what are the powers of this auditor in this story? So in classical computing, there's sort of this tacit assumption that you'd imagine the auditor could at some point throughout the computation, you just copy the memory state over to like another register and then use the other registers to do whatever things you want to do in terms of auditing. I don't understand, but I don't understand what auditing would even mean in quantum computing.
Well, okay, so you may want to, for example, understand, so say that your ethical criteria is the evolution must occur in this particular way, or perhaps quantum state must not be one of in this subset of Hilbert space.
But that might be a more difficult computational problem than the original problem, right? So you might be defining like the auditing problem may be infeasible for even a quantum computer, even if the original problem is feasible for a quantum computer. So this is why I'm trying to get at the powers of the auditor, him or herself.
Yeah, well, indeed. I don't know entirely. This is sort of so this is more me raising. So this paper is about essentially trying to set out a set of proposals for what may be interesting research questions, and then I sort of in another paper I sort of presented.
Yeah, well, I mean, it's sort of an annoyance I have with people in ethics, which is that they assume that rationality is for free.
Oh yeah, no, totally, and that is, yeah, totally, and I suppose in this paper I try to call attention to that, which is that was the point that I was trying to make. Although I sort of, I can't give you particular examples and details because I sort of haven't done the thinking yet. But that is exactly the point that I've tried to make to people in ethics, that the imposition of constraints, we can call it, is resource constrained. And
I will use you as a mouthpiece then. I would suggest going to them and saying, rationality is not free.
Yeah, no, totally. And I love, essentially, there's a great book by Vincent Conitzer on computational social choice, which I often send in the classical sense. I'm like, hey, hang on a second, read this. So yeah, totally. So in some senses, and this paper tries to, in some sense, cover a whole range of different areas. So yeah, so I'm often trying to raise that flag with people in the ethics departments.
Okay, so my second question is, why does that have anything to do with quantum computing specifically? That's an issue in classical computing too, even if people fail to recognize it.
Why does auditing?
So the idea is that auditing requires an auditor, at least if you're going to believe me for a minute. And the auditor has, one would hope, not infinite computational powers, because that just seems absurd to me. So, but if the auditor has limited computational powers and, various limitations according to the laws of physics or something like this, then that is actually a statement about just ethics, like the relationship between ethics and computation more broadly. I'm not quite sure what the specific point about quantum computing is here.
Well, if you want to know the quantum state, you can't just necessarily copy the register over in the way that you've talked about classically. You have to.
Okay, so let me just try to distill what I think you're saying. So what I think you're saying is that if you require your computational processes to be auditable in order to be ethical, then one must take into account the powers of the auditor, and one cannot assume the sorts of powers one is used to assuming about auditors, some of which are powers that don't make sense in a quantum mechanical universe, even if they do make sense classically, and others don't make sense even in a classical universe if you assume that the auditor is not a god.
Yeah. So even if you are even if you say, let's not assume omniscience, then there are, for example, if you're trying to reconstruct a quantum state through, so if you're doing quantum tomography, there are constraints on tomography, which may mean that, for example, you are less confident than you felt like you needed to be if you were dealing with a classical state. So
Okay, thanks. I think I understand your point.
yeah, but they're very good points, and I really appreciate people. Like,
Well, they're your points, so of course they're good points.
Oh well, it's just I sort of I often again give these talk to more people from the ethics school, so it's really refreshing to hear these kind of queries. So and look, this is very early research, and so sort of it's more just trying to raise this as something that people may want to look at. Sorry, let me do this. Okay. And look, I sort of have this. It's more just like a throwaway line, which is that if we care about auditing, does auditing, like, what's the relationship between auditing and proof? Now that's a whole interesting subfield in classical computer science itself. But it may be that there's a research direction there, if there's funding available, to look at, well, hang on, okay, so if auditing in the classical sense does require some type of proof procedures, or some then again, if we're trying to prove or be confident of particular conclusions about quantum systems or how they evolve or quantum states, then we may need to draw resources from quantum world to deal with proofs regarding quantum algorithms. What that may look like is an open question. Now, for again, mainly the ethics departments that I do this preso to, I sort of set out, and there's a few lines in these slides which computer science people may jump out about, but again, I've tried to oversimplify. But essentially, I've sort of tried to say to people in computer science, hey, when you come up with when you're looking at ethical problems, do consider issues from computer science. Now, computational social choice. So if you're interested in the connection between ethics and computability and complexity, then the subfields you may want to consider are things like computational game theory, but also, again, there's a whole very interesting rich field called computational social choice, and that looks at, for example, how an agent may reach what you might call an ethical equilibria when it's competing, when it has competing policies, for example. So in this bit, I'd say, hey, there are 4 C's. If you're doing ethics, there are 4 C's from computer science you might want to just consider and have in the background. So try and have these in mind when you're thinking about ethics, prior to saying, hey, let's just make our quantum computer do this. So one is computability. So is the type of ethically constrained quantum computation computable? So can we reach the subspace of Hilbert space within which our particular quantum state that we are trying to reach is permitted to reside? Is it efficient or feasible given the resource constraints? So if we impose a criteria, and again, people would rightly say, give us an example, and I don't have exact examples now, but one thing I'm very mindful of in the classical computational sense is people imposing ethical constraints, and then coders try to code them and go like, it just can't be done, or it pushes the overhead into some other. I mean, I can't think of any off the top of my head where it pushes the overhead into a different complexity class. But the point is, people need to think about, well, hang on a second, to your point that you just raised, how does imposing a constraint change the efficiency of the algorithm? That's really important. It is, all ethics is a trade-off. It may be that having the perfect home loan algorithm, either classically or quantum, means that we can't even do the computation. So that means we're going to have to live with some amount of unfairness. So it's important to understand. Again, this is for a non-comp sci audience. Just so what complexity class does the algorithm live in? Does, again, imposing a certain constraint change the complexity class? Again, it may not. This may just be like no. Again, same point. Do the constraints render the problem intractable? Again, I'm still not trying to open the can of worms that is quantum complexity, but it's more to put this on the radar of people who do ethics. How important is consistency? So again, this is a question of, you know, and it's not just, this is not a quantum specific problem.
But interrupt, like, isn't that about, like, I'm not sure that process means deontological.
Well, I
would think that's more like virtue ethics.
Okay, so, well, I would say that that's, I mean, I don't even personally agree with the full distinction necessarily between deontological and consequentialism, but I would say actually that it is. I would say that it isn't appropriate because deontology is fundamentally about rules and duties, and that is a specification of, if you like, what the rules of transitioning between states are. So I actually think that it is the appropriate term, but I could be wrong. There is a whole debate about whether whether subclasses of ethics are well defined, or whether the distinctions are themselves well defined. So, you know, as I'm sure you're aware, there's a whole debate about sort of where is the line, if there is a line between consequentialism, deontology, virtue ethics, and so on. But they're important questions, so.
But the distinction you're trying to draw is between process and consequence, right?
It is, and it's because it's again, these presentations could, the thing is, this is such a sort of, this area kind of overlaps with so many areas that I love those questions about, you know, that's what I partly do at the ANU. But if I go to a quantum group, maybe not this one, and I start talking about that, then there goes my hour. You know, it's like...
No, the reason I'm asking is because I'm trying to ascertain what kind of computational problems you're running into here. So if it's about process, it's about, like, you know, it's one thing to compute something, it's another thing to say that the computation itself is sort of obeying certain restrictions. In terms of, but then the consequentialist view is to say, does the computation ever reach some bad state? And these are just different kinds of computational problems. So I'm just trying to keep track of which ones are which. Yeah,
correct. And that is the basic, what you've just articulated is the way that I've attempted to simplify it. So there's in representational justice questions.
Maybe the correct view of ethics is neither of those things. Maybe it's about inputs.
Yeah. Look, I'm not. Yeah, totally. And I really enjoy those questions themselves, and I'm not.
Which totally is what I thought deontology was actually about.
Well, so can't. So I don't know if you're familiar with Kant.
Yeah. Yes. And the reason I'm picking on it is because I think the idea is that an imperative is categorical if you just don't need any inputs, basically.
That's interesting. If you don't need any inputs.
So a hypothetical imperative would be if you do need some kind of input, right?
So I'd say, so categorical imperative, you elevate a maxim to the categorical imperative. It's effectively a universalizing of a maxim. I would say it's actually about a consistency criteria. It's actually why I've got it here.
Okay, fair enough.
But they're very interesting questions, and it'd be great to chat offline if you have time. Again, I don't.
Sure. Yeah. The reason why I'd initially posed the question I did, which I now understand was ill-formed, is I was trying to get at this question of, like, you were talking about process and output, but I didn't understand where input played into this. Maybe the only thing that's ethically relevant is the input to the thing. So if you rediscover gender, even though you didn't have that as a variable that was the input, maybe there's nothing unethical about that.
Yeah, look, I mean, that is one question, one query. There are some other views. There are some other views of what it means, of what an ethical process means, which is, for example, it is not ethical to combine certain information. So sometimes, so
But you can make sure not to combine that information by just not giving the information in the first place, right?
So take the ABS. So this is like something I do a lot. I've done a lot. So when you do the census, for example, you get access to, so if you're a researcher, you can get access to sort of more granular data. But part of the requirement of that data is you do not combine that with certain other data sets that would allow you to re-identify people. And so
but that is about input, right?
Yeah, but I need to use those inputs. I mean, I guess to say,
but maybe the unethical thing is that you gathered information you shouldn't have gathered.
Well, I guess it depends how you frame it, because I may want two sets of data in my algorithm, but I'm not allowed to combine them. So I still want data about, I don't know, people's address and something in the census. And so it's not the case that I'm not that those inputs.
But if it is possible, if you gather those things, but you're not allowed to sort of know them simultaneously, and make use of them simultaneously, maybe the problem is that you gathered too much data. Maybe that just suggests that the data you gathered was itself the unethical thing.
I guess it depends though, because certainly the way that the ABS rules are written is not that the gathering of the data is I mean, I guess it depends.
I'm suggesting that the government might be wrong about something, but this is probably a better offline discussion. I will just simply comment that I use ad blockers for ethical reasons.
Yeah, no, totally. Yeah, no, totally. I'm totally about privacy myself.
But the reason I'm about privacy is for ethical reasons, because there's certain kind of inputs I think they shouldn't be allowed to take, and that's where I think the ethics lies.
Well, again, there's a whole debate about that as well. Privacy is not an absolute.
And that debate is not present in your consistency thing, because you're only talking about process and outcome, whereas I'm asking why input is not part of this story as you're presenting it.
No, again, I'm not. Input could
is my question / criticism clear now? It wasn't clear before, but have I made it clear?
Yeah. So certainly, what one may say that there are prescribed information, as in certain information just should not be computed, but in some ways
should not even be made available.
Well, yeah, again, but then you might say, okay, but the gathering process itself is a form of computation, therefore by saying
no, I disagree with you. The gathering process is not a form of computation.
I would say that it is actually, because when you're going out and
hard disagree.
Well, I guess we'll have to agree to disagree. I think you are.
I don't agree to that.
Yes, in which case you can just reframe any gathering process, any input as a.
That's the thing I'm disagreeing with. I don't think that any gathering process is purely a computational problem, for the same reason that there's a big distinction between being an empiricist and being a rationalist.
Okay. You and Elijah, can we keep this discussion for after?
I'll shut up now.
Yeah, sure. I've got to go in 9 minutes anyway, so I might just quickly skip through, but please do reach out to me online. Again, I say, when I speak to ethics departments, I say, you got to think about concepts of controllability and then interpretability. These are important. Again, I don't have time to sort of go through them. Okay, so I wrote a paper early this year on QFML. So essentially, sort of takes concepts from fair machine learning and looks for quantum analogues of them. I would, again, if you're interested, let me know, or just Google it. It was AIES 2021, which is an offshoot of AAAI. Sorry, just to skip through. This is essentially just happy to do a presentation on QFML if anyone's interested. And then I often say to people, okay, you got to consider things like privacy and so on and so forth. I don't sort of have time to get through all of this. So I don't know how useful it is for me just to skip through. But for example, there are issues to do with, so oftentimes, particularly in computer science world or in technical world, people are concerned about, hey, we are concerned that people can crack codes, but sometimes we need to crack codes. So it's not the case that that all information in all circumstances should always be private or inaccessible. Ticking time bomb is a classical example. So there's this question about, well, if people do have access to technologies that truly cannot be decrypted, is that problematic? That is a big problem at the moment. So although we can be cozy from our little research groups because it's not our job to sort of keep the world safe, for those people whose job it is to keep the world safe, uncrackable encryption is a problem. And so it's an ethical issue that needs to be discussed if quantum technologies may expand the ability for people to encrypt their data in a way that cannot be decrypted. So I just raise this because there are two sides of this issue. It's not always, oh, quantum computers are bad because they can help you decrypt. In the paper, I talk about who gets access. It's not really a specific quantum issue. It applies to all technology. One wants to generally make sure that there's equal access to the benefits of technologies and so on and so forth. Yeah, again, if you're interested in the whole decryption ethics point, there's a paper on rules in arguments that argues that unbreakable encryption is unethical from 2017. It's an okay paper, but it's an example of the kind of point I'm making here is beyond the particular ways in which quantum computation unfolds, there are consequences which arise from quantum computing if certain things are true, so on and so forth. But if our dreams about quantum computing are correct, then again, it may give rise to these other issues around access to decryption technology. Should anyone be able to jump online, and if we have online cloud quantum computing, which enables us to run arbitrary algorithms of our choice, should I be able to go on there, run an algorithm to to decrypt the data of someone I know? Or should I not be able to run that algorithm? Now, you may say, we don't even have that algorithm. There's no real quantum computing platforms that really work, so who cares? But again, this is part of this paper saying, well, if that technology existed, if someone could jump online and had access to the capacity to decrypt their neighbor's information or some other information, should they have access to it? So it's just to sort of raise this as a potential area for research. Again, if you're interested in ethics, there's a whole field of social choice theory, computational social choice, welfare theory. You know, I mention this in this slide because I say, hey, people, again, you be aware of impossibility theorems, be aware that there's a whole field of ethics out there which has considered a lot of problems. Don't just jump into this thinking, I can work it out myself, which I'm sure you can, but it's always good to see what other people have thought. Talk about quantum simulations, summary. Okay, summary, I believe that there is an argument, particularly for QFML, so sort of at the deep brain computational level, to explore the ways in which ethical constraints may differ in terms of application or form on in terms of quantum computation. I set out for a sort of general abstract way of classifying into processes and outcomes. Appreciate, again, for people that have more background in ethics, there are so many ways to slice up the ethical pie, but for your average quantum researcher who's never going to read Rawls or Harsiani or Kant, then sometimes it's better to keep it simple, but appreciate that there may be other ways you can frame it in terms of inputs rather than processes. And I guess I just finished by saying, again, for people in quantum, hey, there's a field of ethics. It's not all hand wavy. There are people with scientific backgrounds. Think of ethics as, in the best case, providing decision procedures for how you should resolve ethical problems. And so, yeah, that's me skipping through. Just quickly, so anyway, following on from this research, I've got a bunch of papers in train with a number of people, but I'm also I've been on this World Economic Forum committee. So the World Economic Forum wants to do first cab off the rank with a quantum ethics principles process. It's been an interesting process. There've been people from all around the world, research groups. I've been helping draft that document. It suffers from the thing that you get with all documents if you try to draft them with a large group of people, that it's a bit vague and wishy-washy, but that will be coming out in June. And so the idea is to provide a vague, and I say vague because it has to be vague, set of guidelines or concepts that people in the quantum community, people that do quantum algorithms, people that work in quantum in government, for example, people that work in academia, can use in order to start thinking about the ethics of quantum computing. And yeah, if you've got any questions, do reach out to me. We'd love to chat, hear more comments, criticisms, or chat about even working on stuff together. So thank you. I hope that wasn't too boring. That's it.
Thank you, Elijah. That
Thank
was,
you.
yeah, very different than our usual seminar, but I think people really appreciated it.
Yeah.
Do we have questions from anyone other than Yuval?
Yeah, well, do reach out, Yuval. I'm very, very interested to continue chatting. I think you made a lot of really good points, and it's, you know, it's good to speak to someone who's from quantum but has a background in ethics, or at least has some kind of understanding, because oftentimes you know, it's hard to combine those two things. So yeah.
11 years of arguing about veganism.
Yeah, no. Look, it's great. I basically don't have that many people to talk to about it, so let's catch up, definitely.
I'm writing you an email, don't worry.
Yeah.
All right, so in that case, yeah,
Okay.
let's thank Elijah again.
Thanks,
And
everyone.
we'll lead to many more discussions offline.
Okay. Thanks.
Bye.
Thanks. Bye.